Configuring firewalls. Learning objective and key concepts. Learning objective. Describe the fundamental functions performed by firewalls, common firewall technologies, and the elements of firewall implementation and configuration. Key concept. Firewall rules, firewall policy, firewall limitations, firewall enhancements, and management interfaces. Firewall rules. Firewalls filter traffic using rules or filters. Filters are instructions that evaluate and take action on traffic traversing the network, used to control which traffic enters or leaves a secured network area. There are two main philosophies or security stances in firewall rules. It's either default deny or default allow. Default deny, also known as deny by default or deny all, assumes that all traffic is potentially malicious or at least unwanted or unauthorized. Everything is prohibited by default. Just the opposite, default allow, also known as allow by default or allow all, assumes that most traffic is benign, everything is allowed by default. Deny by default, allow by exception. Also benign, the desired and authorized traffic is identified. An exception rule grants access to the network, places less of a burden on the security administrator. Whitelist action, whereby only defined exceptions are allowed through, and is a little bit more secure. Default deny by exception is a practice as malicious or unwanted or unauthorized traffic is identified. An exception rule blocks it. The security administrator is on constant watch for activity. Blacklist action, whereby everything is permitted with a few noted exceptions. Here we see the pfSense firewall interface and the default rule configuration interface showing a default deny as the last rule. And as firewalls read access list, which this is, from the top down and in order. So the traffic gets validated across the first access list, which is IPv4, TCP, protocol, destination DMZ, port 22 or SSH. If it doesn't meet that, it goes to the next rule and looks for UDP traffic on the WAN address on port 1194. If it doesn't meet that, it gets to the last option, which is deny all, and puts that traffic in the bit bucket and will not pass. Defining firewall rules is an essential part of a security policy. If the policy does not predefine rules, perform the following procedure. Inventory all essential business processes and communications that will cross the firewall or checkpoint. Determine the protocols, ports, and internet protocols or IP addresses of valid traffic for both internal and external hosts. Write out the rules or use a firewall rule designer or simulator. Test the rules in a safe non-production environment. Obtain written approval for the rule set from a change approval board or administration. Document the rules in a security policy procedure amendment and submit the amendment to the security policy management team or an administrator for inclusion in the official document. Common types of rules found on most firewalls. Access to insecure internet websites or HTTP. Access to secure internet websites, HTTP over SSL or TLS. Access to other internet website protocols of SQL or SQL, Java, and so on. Inbound internet email and outbound internet email. Inbound and outbound communications. Most network communications are two-way transactions, exchanges, or sessions. Rules usually allow inbound responses to an initial outbound request. A single rule can sometimes define both the outbound and inbound communication parameters. Consider rules that manage inbound communications for externally initiated communications. ACLs, or access control list, are not rules or filters. Rules are written expressions of an item of concern and actions to take when the item of concern appears in traffic. Filters are the same as rules or intended to emphasize the intention to block or deny unwanted items of concern. Emphasize the intention to grant or deny traffic on an access control or authentication basis. Focus on controlling a specific user's or client's access to a protocol or port. Composing firewall rules. You have the base protocol set as either TCP, UDP, ICMP, and potentially other layer 2 and 3 or 4 protocols. The source address set as a specific IP address, a subnet, a range or of addresses, or any of the possible addresses. Source port set as a specific port, a set of ports, a range of ports, ports less or greater than, or any for all possible ports. Firewall rules also contain target addresses set as a specific IP address, a subnet, or a range of addresses, or any for all possible addresses. Target port set as a specific port, a set of ports, a range of ports, or the word any for all possible ports. Action. Standard actions are allow, deny. Some firewalls include a log and alert actions that allow additional actions in a single rule. This is an example of the pfSense rule configuration interface, where you identify an action, whether you want to disable or enable the rule, the interface, what interface you want this action to occur on, and the address family, IPv4, IPv6, and the protocol. So this is where you would configure those parameters that you want to take an action on. Here's the common structure of a rule. Firewalls read from left to right. This table view will identify a protocol. Protocol is IP, TCP, UDP, ICMP. The source address. Who's the conversation coming from? The source port. What port is that conversation coming to us from? And that should be an empirical port. Target address was who do you want it to talk to? And what port? So the target address would be your web server, your machine, and on what port? 22 for SSH, or 80 for HTTP, 443 for HTTPS, and the action. Do you want to permit or deny? Here's an example of an outbound rule. The source address and port are often set as any, unless the rule applies to specific systems or ports. The example here, a rule that allows any internal client on the 192.168.42.0 sub network to access any insecure internet website. So we're saying protocol TCP, any host in this network, 192.168.40.0/24, any port, source port, any destination address on port 80 allow. We'll continue with another example here. A rule to allow access to any secured internet website would change the destination port to port 80 or 443. Again, protocol TCP, source network would be from this network 192.168.42. Source port would be any. Destination address would be where it's going to, would be any address. And then on port 443, which is HTTPS, allow that to happen. Here's another rule. A rule to block internal clients from accessing internet-based FTP sites would be protocol TCP, the network, the source would be any port, the destination would be any address on port 21, deny. Here's examples of inbound rules. So this would be people coming into your network. The source address and port addresses are often any unless the rule applies to a specific system or ports. So the reverse here is from our other outbound rules, these are inbound rules. A rule that allows any external host or client to access an insecure website hosted on 192.168.42.98. So that's the host, that's the web server. So let's look at our rule again. The protocol is TCP. The source is anybody coming in, any address coming in, any port coming in, destined for 192.168.42.98, listening on port 80, allow that traffic. Another example to a rule to deny external host access to a telnet server hosted on the same internal system as the web server. So our rule is TCP, that's our protocol. Anybody, any source coming in, any port coming in, destined for 192.168.40.98, it's the same host, but now we're talking on a different port 23. If it tries to connect to that server on port 23, it's going to deny that traffic. Here's an example of how those firewall rules would be stitched together. And if we go down, we can look at all the rules from top to bottom. This is how the firewall would read it. It would read the first rule. If it doesn't meet that, it goes to the second rule. It will read that. If it doesn't meet that, it goes to the next one and the next one. And then if it doesn't meet any of those parameters, the last rule is the default by denied by all. That's TCP, any source, any port destined to any address on any port is denied. So that's what stops all the traffic coming into your network if it doesn't meet the rules above. Other thoughts for composing firewall rules: keep the rule set as simple as possible. Document every rule. Use a change control mechanism to track rule modifications. Always confirm default deny before using changed or updated rule sets. Firewall rule ordering is critical. The direction matters. Validate both source and target address. When the wrong rule is positioned first, it creates a potential loophole. A loophole is a flaw in the logic of filtering that will allow an unwanted action to occur. Place a critical deny exceptions first or early in the rule set. Rules pertaining to more common traffic belong closer to the top of the list, and the universal deny rule should be the last and final rule. Use fewer rules rather than more rules. What should you allow and what should you block? Complete a thorough inventory of network communications. Include protocols and ports in use, as well as source and destination addresses. Determine which communications are mission critical, important, optional for personal recreational use, or actual malicious. Block any traffic you deem malicious or just unwanted, whether through an explicit deny or via a catch-all default deny. Again, what should you allow and what should you block? Commonly blocked communications are ICMP traffic originating from the internet. Any traffic directed specifically to the firewall, any traffic to known closed ports, any traffic to ports of known malware used by back office, inbound transmission control protocol or TCP, port 53, which is DNS, to block external DNS zone transfer request, inbound UDP port 53, which is DNS, to block external DNS user queries, any traffic from IP addresses on a blacklist, and any traffic from internal IP addresses that are not assigned. Essential elements of a firewall policy. A written firewall policy provides several benefits and serves several purposes. It's a guide for installation, a guide for configuration, a tool to assist in troubleshooting, guideline to detect changes and differences, and a mechanism to ensure consistent filtering across all firewalls. Additionally, the firewall policy should also address what to log, logging location and redundancies, where to store log files, how often to review logs, what add-ons or enhancements to use, who is responsible for firewall administration, how to access firewall configuration interfaces, where to physically and logically locate the firewall, what level of physical access control is necessary, what form of backup or redundancy is present, how to manage encryption and where to use or disallow it, how to deploy and configure IDS, IPS to interact with firewalls. Limitations of firewalls: programming errors in firewall software, exploitation of software code plugs, software may be vulnerable to buffer overflow attacks, fragmentation and fragmentation attacks, overlapping, internal code planting, and denial of service or DOS flooding. Here's some examples of fragmentation and overlapping. Normal fragmentation, you can see the example there. Overlapping, you can see how the packets would overlap and the IP header would be discarded. And then overlapping header and data sections is another example. Improving performance of a firewall. Network communication speed is a common concern. Properly installed firewalls should function at wire speed. Wire speed means the firewall does not introduce any delay or latency in communications. Two primary criteria to improve firewalls are caching and load balancing. High availability, often associated with load balancing, and network availability, measured as the percentage of time when a service or device is available to users on the network. Caching holds often accessed content in a storage of memory on the firewall. The content can be retrieved from a cache instead of the original source, improves performance by borrowing from proxy servers, transforms the firewall into a proxy server of sorts. Load balancing distributes the firewall filtering workload across multiple parallel firewalls, allows deeper packet inspection while maintaining wire speed, and provides redundancy and fault tolerance. In this example, you can see how multiple firewalls are used in a load balancing configuration to balance the load of the internet traffic coming into the network and the network trying to get to the internet would load balance in both directions. The downside of encryption with firewalls. Benefits of properly used firewalls: protect data in storage and in transit, provide confidentiality and protection, prevent unauthorized third parties from gaining access to secured content. The downside of encryption with firewalls is the firewall is not the intended destination for encrypted communications. The encrypted data cannot be filtered by the firewall, not useful to protect against malicious traffic when filtering tunnel mode encryption. The firewall is usually unable to perform network address translation, or NAT. In this example, a firewall deployed as an SSL TLS endpoint to allow for web traffic filtering. We have our web server that's sitting in our DMZ. It's communicating with the firewall with plain text web communications, and the web client is asking for a web page from our web server, and they get that through HTTPS TLS. That creates a tunnel between the client and the firewall through the web browser using TLS as the encryption, and that's how we can securely talk back to a public web server. So when you're looking in your web browser and you see HTTPS and the URL, this is what's happening between your web browser, you being the client, talking to another web server on the internet. Some firewall enhancements allow for malware scanning. Also, some high-end firewalls will act as an IDS and IPS. They also will include VPN endpoints and unified threat management and virtualized firewalls. Management interfaces on firewalls. A firewall management interface may be command line based or graphical. Secure the firewall's management interface physically and logically. Use strong authentication process. Limit the methods to access a firewall's management interface. Consider the communication pathways for accessing the management interface. Disable access to the management interface on every physical network interface or port that faces outward. Configure the firewall to record all attempted and successful connections to the management interface into a log file. Verify all settings remain as configured. In this example, we can see that we've accessed a firewall, which is the pfSense firewall, via the command line using SSH. Once we've successfully logged in, we can have access. We can see the options that we have. In this example, we see a GUI, or graphical user interface, to manage the firewall. In summary, we've talked about firewall rules and how they work. We've talked about firewall policy, how to make those and how to enforce those, firewall limitations, firewall enhancements, and management interfaces.